Okay, so this will go in your notes for section 2-1 on solving systems of equations. Solving systems of equations. And first I want to go through the different methods, and you've had some of these already, and some of them you'll get in this class. The methods used to solve systems of equations. And we're going to go back and review some of the different types. The first one that you probably did in Algebra 1, even maybe in pre-algebra, was graphing, where you graph two equations, two unknowns. Okay, the second method is substitution. Where you can solve for either variable and substitute it into the other equation. The third method is linear combination. Some authors call it linear combination, some authors call it elimination. Sometimes some authors call it addition, subtraction, and sometimes it involves multiplication and then addition, subtraction. But I think your author calls it linear combination. Okay, and then you also last year did matrices, probably with 3 equations, 3 unknowns, and we'll go back and review that. And then probably one that you have not used is determinants. So there's at least 5 methods, okay, that we're going to talk about. And I could give you one problem and say work it all 5 ways, okay, which your answers ought to be the same. So I'm not just concerned with can you get the answer, I'm concerned with do you know the method, okay? So we're going to go back and review, and I'm going to take you through a couple of problems. Say they ask you to solve by graphing without, this W/O means without a calculator, and you can abbreviate it. Solve without a calculator, with a calculator, by substitution, and linear combination. So we're going to take this one problem, the first example, and we're going to work it 4 ways. Okay? So 2 equations, 2 unknowns. Say they give you 2x plus 3 equals y, and y equals a negative 4x minus 5. It's 2x plus 3 equals y, and y equals a negative 4x minus 5. Now, if we were doing that by without a calculator, remember, if all else fails, you can always make a table of ordered pairs. But that's the long way. The short way would be to do the y equals mx plus b, slope-intercept form. Okay, so, and I don't expect you to have graph paper. We're just going to do it on paper. Okay, so remember in this form, this would be our y-intercept, and this would be our slope. So you do the y-intercept first. You do the b. So go up 3, just sketch. Okay, and the slope would be 2 over 1. So from that point, go up 2 and go to the right 1. Go up 2 and go to the right 1. Or you can go down 2 and to the left 1. Down 2 and to the left 1. So you should have a line, and that's pretty rough. A line that looks like that. Okay with that one? Okay, and then the other one, it goes through at negative 5, so go down 5, and then the slope is negative 4. So you can go down 4 and to the left 1, or you can go up 4, or I said the left one, right one. Now it's left one. Go up 4 and the left 1. So you should end up with a line something like that. And our solution is this point right here where it intersects. But without having graph paper, even if I had graph paper, I can't tell if I'm on the grid. Okay? So I can do it by hand. The only thing I know is yes, I have a solution where it intersects. Okay? That's as much as you can do there. Now do that on your calculator. Okay? So you need to hold up the calculator. Okay, on the calculator, I need you to go to the y equals upper left hand corner. Okay. And make sure you're in mode. I guess we should say mode because some of you we did forward graphing. And make sure you're in function mode. Okay, and you go to y equals. Put in that first equation, y equals 2x plus 3. So put your cursor right here. Put in the 2. Okay, and then you need the x t theta m t. Okay, right here. 3x plus 3. Okay. Okay, and then I want you to do zoom standard. Zoom on the top row. Zoom standard. Zoom 6. Okay, so that should look like our first line that we graphed, the black one. Okay. Everybody good? Anybody need help? Okay, go down on the y equals, go to y equals, go down to y sub 2. Okay, and then put in the second one. We need negative 4x minus 5. Remember to use the negative sign. Negative 4x minus 5. It looks like that. And then hit graph. Okay, and that should look like our second line. Anybody need help? Good. Okay, now we can find where it intersects. Okay, if you look right above the trace key on that top row where it says calc, use second function calculate. Second function calculate. Okay, and look at our choices. We know it's an intersection. Okay, so do number 5. Just press 5. And get it close. You should have an ordered little cursor, blinking cursor. Use your arrow keys and get it close to that point of intersection. Doesn't have to be exact. The closer you move, the less the calculator has to be. It says first curve. We're on that first line, so press enter. Now it's asking for the second. We're on the second curve. Now we're on this one. Just press enter. We could put in a guess, but mathematicians are lazy. So I'm just going to press enter. Okay, and there's the intersection. This, don't show that again. Okay, so now the ordered pair where it intersects. If I did this by the calculator, negative 1.3333 repeating and 0.333. Now, if the author said, give me an exact answer, this is rounded. The exact answer is negative 4/3 and 1/3. And that I would prefer this one. Okay, that's the exact. Okay, so we did this by, make enough notes, we did this by second function calculate intersect to find that ordered pair. Okay, and that ordered pair satisfies, I could plug that ordered pair in for x and y in here and it would be a true statement in both of them. That means there is a solution. Okay, if you look at that graph, there are 2 separate lines. Okay, you agree? There's 2 separate lines on your graph. If you can see 2 separate lines, they have a special name. They are called independent. Independent means you can see the separate lines. If there's a solution, and the solution is that ordered pair, then they are called consistent. Consistent means there is a solution. Independent means there's two separate lines. Consistent means there is a solution. Okay? Everybody good on number 1? That's, we did it without a calculator, with a calculator. Now we're going to do it by substitution. Okay? Draw a little separator there. Okay? and I'm just going to abbreviate it by substitution. Okay. Okay, they gave us y equals 2x plus 3 and y equals a negative 4x minus 5. So I've already got y by itself, so I'm going to substitute that in for y. Okay? Or another way to say that, y equals y. Substitute this in on one side, this in on the other side. So you'd have 2x plus 3 equals negative 4x minus 5. And solve. So add 4x. So I get 6x plus 3 equals negative 5. Subtract 3. 6x equals negative 8. Divide by 6. Negative 4/3. Negative 8/6. And in here, May, because this is your first time with me, we reduce all fractions all the way through. Okay? Okay? Okay, so that's your x. You can sub that back into either one of the originals. Say sub that back into here. Okay, and solve for y. Okay, so if I did y equals 2 and then negative 4/3 plus 3, and this 2 is like over 1, so that's y equals negative 8/3 plus 3 over 1. 3 is 9/3, so y equals negative 8/3 plus 9/3, so y equals 1/3. And they will always write the answers as an ordered pair, alphabetical, so it's negative 4/3, 1/3. So substitution is another method. Okay? Any questions on that one? Okay, then got another little separator. Okay, then linear combination. On linear combination, you always try to line up the x's, the y's, and the constants are on one side. So I would line up, like as an example, negative 2x plus y equals 3, and 4x plus y equals negative 5. Now, if I want to eliminate the y's, I could multiply by negative 1 all the way across. Okay. If I wanted to eliminate the x's, I tried to get these opposites. I could multiply this by 2 on both sides. You can do it either way. If I eliminate the y's, I would say multiply by negative 1 all the way across. That'll change all the signs. Okay, and then that'd give me a negative 6x. The y's drop out, equals 8. Divide by negative 6. And x equals, oops, negative 6, sorry. Change that. And that'd be a negative 4/3. And then you sub that back in and get, okay? But the main thing when you do that one is to remember multiply on both sides. And I want you to show it. So like if you were going to eliminate, if I was going to eliminate the x's, I would multiply on both sides by 2. Try to get their signs opposite and then add. Okay? Okay, everybody good on that example? That's all 4 methods. Okay, remember most of this? Hopefully. Okay, second example. Second example. 2 other equations. 2x minus 4y equals 5. And 6x minus 12y equals 15. 2x minus 4y equals 5. And 6x minus 12y equals 15. First, look at those 2 equations. They are the same. One is a multiple of the other one, right? If you multiply this 2 by 3, you get 6x. 4 by 3, you get the 12. 5 by 3. It's gonna be the exact same line. Okay, if you graphed it, it's the exact same line. So if one line lies right on top of the other one, what are they called? Dependent. They are dependent, and what type of lines? They're not intersecting. They're still consistent. They are coinciding lines. Coinciding. These will be coinciding. And if they said do this graphically, take one of the equations and graph it. So I'm going to take this one, the top one, and graph it. Okay, I'm going to add the 4y and subtract the 5. and then divide by 4. And that 2x minus 5 is a polynomial divided by 4. That 4 divides into both of them. So it would be 2 fourths, which would be 1/2 x, minus 5 fourths equals y. Okay? Now, don't let the fractions scare you off. If they said do this graphically, okay, you do the negative 5 fourths first. Okay? So it crosses at negative 4 fourths would be negative 1. So it's a little bit more than that, so it's going to cross a little bit below negative 1, negative 5 fourths. The slope, remember, is rise over run. So from that point, you would go up 1. If I went up 1, I'd be right here, right about there. And then to the right 2. Say I'm over here. Okay, so I get a line that looks something like this. Okay. If I graphed this line, I would get exactly the same line. Okay? Now, that means every point on that line is a solution to both equations. If I said, list all the ordered pairs that satisfy that problem. If I said do that for tomorrow, if I said do it for next year, if I said do it for an infinite number of years, you could not finish that problem. Okay? So, you have to write it out in words. There's no way to list them all. Okay, and this is how the author writes it. Okay, get used to writing it. Okay, it's all ordered pairs. Okay, all ordered pairs x, y on the line. And then you have to give the equation for the line. 2x minus, and I don't care if you use this or if you use this, you can write it either way. The author did the original. All ordered pairs x, y on the line 2x minus 4y equal 5 are solutions. So if it's a coinciding line problem, you have to write out a sentence. Okay? And one line lies right on top of the other one. So you will write they are dependent. One depends on the other one. There's still a solution. There's an infinite number of solutions, so it's consistent. Okay? Okay, last example. All a little separator there. Problem 3. Y equals negative 2x plus 3 and y equals a negative 2x minus 7. Okay, as soon as you look at that, you should be able to tell the slopes are the same, but the y-intercepts are different, so they are parallel. Okay? I always check the slopes first. If the slopes are the same, and y-intercepts are the same, then it's dependent, coinciding. If the slopes are the same and the y-intercepts are different, then it's parallel. Okay, so picture-wise, go up 3, plot a point. Slope is negative 2 over 1, so go down 2, left 1, down 2, left 1. We should get a line that looks something like that. Then do negative 7, so it crosses at 7, down here at negative at 1, 2, 3, 4, 5, 6, 7. And slope, like that. They should kind of look parallel. Okay. So if the slopes are the same and y-intercepts are different, they are parallel. Can you see two separate lines? Yes, then they are independent of each other. Is there a solution? No, so inconsistent. Inconsistent means not a solution. Prefix in means not a solution. Okay? Okay.